Welcome to this tutorial where we will build a facial recognition door lock system. My name is your name, and in this session, we'll learn how to create a smart door lock that uses facial recognition technology to enhance security. Before we dive in, let's discuss the project's prerequisites. We will be using Java, OpenCV for image processing, and a webcam for capturing video input. Please ensure you have these tools set up in your development environment. Start by setting up a new Java project in your favorite IDE. Ensure you have the necessary libraries installed. For OpenCV, you need to download the Java bindings from the implementation's official site. Let's proceed by setting the environment variable for OpenCV. On Windows, add the OpenCV bin directory to the system path. On Linux or Mac OS, you can link it using your terminal. In your project, create a folder named src and a package named com.facialrecognition. In this package, we will be placing all our Java files. Make sure you have the OpenCV libraries included in your build path. Let's begin coding. Start by creating a face recognition class. This class will encapsulate our facial recognition logic. Within the constructor, you can notice we initialize the video capture object to use the default camera, which is indexed by 0. Next, we instantiate a Cascade classifier to perform face detection. Make sure you download the HAR-Cascade XML file and provide its correct path. Next, let's add a method to capture and process video frames. This method will detect faces in real time using our webcam. Add the following method to your face recognition class. In this capture video method, we are continuously reading frames from the camera. We then use the detect multiscale method to find faces and draw rectangles around them to visualize the detection. Let's break down the significant components in the capture video method. Matte frame represents an image in OpenCV. We enter a loop to continuously read camera frames and check for face detections. When faces are detected, we incrementally draw a rectangle around each face in the video feed. Now, let's add functionality to save the faces detected for recognition purposes. This means we'll need to implement an additional method that captures images of the recognized faces and saves them. The Save Detected Faces method takes a frame and an identifier as input. This method utilizes the imkDex class to save the captured image to a folder. Depending on the identifier, you can create unique files for different users. Next, let's implement a way to recognize the faces. For this, we will need to integrate a face recognition model. The easiest way to get started is by using the Eigenfaces algorithm or LBPH, Local Binary Patterns Histograms, provided by OpenCV. Let's start implementing face recognition. In the constructor of our face recognition class, we instantiate a face recognizer, which will be used for recognizing faces. You can choose to train your recognizer with the images saved when a user faces the camera. Now we need a method for training the face recognizer. We will load the saved images and their corresponding labels for recognition. Add the following method to your class. In this train recognizer method, we load the images from the specified directory, read them in grayscale, and use those images to train our recognizer. Each image must correspond to a unique label, which we generate based on the order of images in the folder. Following the training, we need to implement the recognition logic in our video capture loop. Modify the capture video method to include recognition. Here we extract the region of interest ROI using the detected face rectangles and then predict if the detected face matches any name based on the train model. We also draw the corresponding name above the rectangle on screen. At this stage, we have built the core functionality of our facial recognition system. However, we still need to create a mechanism for unlocking the door based on recognition results. Let's implement this by simulating an unlock mechanism using a Boolean flag. The checkUnlock method checks if a recognized face is known. If it is, we simulate the door unlocking process. In a real-world scenario, you would replace this with an actual method interfacing with a door lock mechanism. To finalize our implementation, we'll neatly integrate everything in the main method and create a user-friendly interface to run the system. Create a new class called main. In the main class, we instantiate our face recognition system, call the training method, and begin capturing video. This way, all components are hooked together and run as expected. This is the complete code for our facial recognition door lock system. Feel free to optimize and modify this code according to your requirements. Explore more, like integrating with a physical lock system, adding a database for storing users, or improving the face recognition model. To summarize, we have learned how to set up a facial recognition system using Java and OpenCV, detected faces in real time, saved images, trained a recognizer, and built a simulation for unlocking a door based on recognized faces. If you found this tutorial helpful, please give it a thumbs up, subscribe, and share it with your friends and colleagues who might be interested in building their own smart systems. Thank you for watching. Until next time, keep coding and stay safe.